Hi friends, welcome to Distributed Computing System. Today in this PPT we will discuss the network time protocol. First point, Christian's method and Berkeley algorithms are intended primarily for use within the intranet. The NTP defines an architecture for a time service and a protocol to distribute time information over the internet. Christiana and Berkeley are intranet, and this is used for NTP is used for internet, represents all over the world, we can say, to provide a service enabling clients across the internet to be synchronized accurately to UTC. In this platform we will synchronize the time in the client server architecture, like in a Berkeley's algorithm, that is done by UTC, coordinated universal time. That UTC is maintained with the atomic clock. Although large and variable message delays are encountered in internet communication, NTP employs a statistical technique for the filtering of a time data, and it discriminate between the quality of timing data from the different servers, right? In this protocol, hierarchy of servers and associated with clients are maintained, so the filtering of the timing occurs from one server to the other server using a standard UDP, internet transfer user datagram protocol is also used in a network time protocol. Uses of a NTP. What's the uses of a NTP? To provide a reliable services that can survive lengthy losses of a connectivity, right? It is helpful in a connectivity purposes, to enable a clients to resynchronize sufficiently frequently to offset the rates of drift found in the most computers, right? Which is associated with also the offset values which considered with the higher level of, or say higher hierarchical level of the server to the lower hierarchical level of the servers, to provide the protection against interference with the time services, whether malicious or accidental occurs. This is also one more important use of the network time protocol. Next we will move to the diagram. An example synchronization subnet in a NTP implementation. Here 1, 2 and 3 are the hierarchical servers are maintained. One represent a higher level servers, second represent middle one, third represent the server or the nodes associated with the clients associated with the servers, right? The higher level servers are attached with the UTP, okay, or say the international timing which is maintained, okay. The NTP service is provided by the network of servers located across the internet. Primary servers are connected directly to the time sources such as a radio clock receiving UTC. Secondary servers are synchronized ultimately with the primary servers. First server which is associated with the UTC, second server is associated with the first server, third server is associated with the second server. Like that, the time which is flow from higher level to the lower level. If anything happens, the timing in a lower level clients or the servers, the time is updated by the higher level servers. The servers are connected in a logical hierarchy called as synchronization subnet. Whole levels are called as strata. Primary servers occupy the strata number 1. They are the root here. Stratum 2 servers are secondary servers that are synchronized directly with the primary servers. Stratum 3 servers are synchronized with the stratum 2 servers, and so on. Lower level or a leaf level servers execute in the user workstation, in the sense that third level, if any existed, right, the other levels will be a clients which are connected with the third level. Now here the server which is a server B and sending the request to the server A, again server A is giving the time to the server B, like that it is happens there. For each pair of the messages sent between the two servers, NTP calculates an offset OI. OI is offset which is a time difference between the sending time and with the receiving time, which is which is an estimate of the actual offset between the two clocks, and a delay DI, which is the total time transmission time for the two messages, right? In the sense that offset associated with the delay Combinedly we will call it as a transmission time for the two messages. If the true offset of the clock at a B relatives to the clock A is a O, and if the transmission time of a M and M dash are the T and T dash. T represents a transmission time. Transmission time occurs there at a end time associated with the starting time, and the delay occurs between them respectively. Ti minus 1 is equal to Ti minus 3 plus T plus O. Again a Ti which represent Ti minus 1 plus T dash minus O. Here minus O represent here Ti is equal to, if you are calculating a Ti in the server A, that will be a Ti minus 1 plus T dash. Here you have to consider a minus 0 if it is a lower level. This leads to a delay. Di represent T plus T dash represent again T. By considering T, Ti minus 2 minus Ti minus 3 is equal to T plus 0 will be like that, in the sense that above the equations reducing will gives you Di and O. Thank you for watching.